Today we're going to go over inverse functions. Now it is 4.7 in the book for those of you following along, but it is online day 3.3 online, just to help you keep those separate in your head. Now inverse functions are kind of a weird thing. We use them a bit here in algebra, but you'll also see them again in algebra 2 and then again later on down the road as you go higher up in the math ladder. What I want you to pay attention to as we go forward in this video is how does the normal relation, or the original relation, relate to the inverse. Okay, the inverse isn't just something random that I want you to memorize. There is a relationship between the two. And if you can see that relationship, then it'll help you out a lot. That being said, let's get started. Now, inverse relations happen when you exchange the x and the y coordinates. Okay, remember that, because we're going to be switching the x and the y later on in the video. But as you can see in this picture, when you have your x coordinates and your y coordinates in the a function, the inverse just switches them. Okay, it doesn't do anything else, it just flips them around. Now, I do want you to notice, or at least put into math words, that the domain of the original function becomes the range in the inverse. I'll change color so you can see. Actually, let me rewrite this. Okay, so the domain in the original becomes the range in the inverse, and then the same thing for the range. The range becomes the domain. So just make note of that and pay attention to it, because as we go through domain and range, this is a valid test question. And it really just is that straightforward. So as we go down to example A, to find the inverse of this relation, all I'm going to do is flip each of my coordinates. Now, two things you have to have when you're writing a set of points. Okay, pay attention to my language. I said set of points, which means we need the curly brackets, number one, and then you need the parentheses. Okay, without the parentheses, it's just a list of numbers. So make sure you have your parentheses. All I'm doing, as you may notice, is switching the x and the y coordinates. And close my curly brackets. As a reminder, whenever you have a list of anything, points, numbers, you always use set notation, which is those curly brackets. All right, you guys find the inverse of b. And here's your answer. Okay. Make sure you check and have all your points and your signs in the proper places. Make sure you have parentheses around each ordered pair, and make sure you have your two curly brackets. All right, now as we move on to graphing the equations, it's a little easier to see how they relate. Okay, not that we couldn't see a bit of the relation with the points, but it's always nice to have a picture. So first thing we're going to do is graph the original relation. All right, so that would be -4, 4, 3. I'm going to use two different colors so you can see the difference. I advise you to use two different colors in your notes just to make it clear what you're doing. Okay. There's our original relation. Now I'm going to find the inverse and then graph that relation. So I'll change and go to red. I'll change and actually go to green. I'll use red for something else. So I have -3, -4. There's my inverse points, and I'm going to graph those. As we graph, notice, or just start paying attention to how the two functions relate to each other. What do you see is going on? And there's our inverse. Now, as you're looking at this picture, you might notice a few things. One of the things I hope you notice is how the points kind of seem to line up with each other. Now, what's actually going on in this picture is that the green line, the inverse function, is a reflection of the original function over the parent function. And there it is for you written down here. Okay? That's how these points relate. All of these points go to the parent function and then reflect over, and that's how you get to all of them. This is true. This reflection is true of every single inverse graph and the original equation and the original function. Now, it may not always look as obvious as this, but that is the case 100% of the time. The inverse is always the reflection over the y-axis, or over the parent function. And the way we express this, because if you've noticed there's a lot of words going on, the way we label these graphs is we label the blue graph, our original, as f of x, and our green graph, the inverse, as f inverse x. Okay? The other way you could say it is the inverse of f of x. And I'll write it up here in black so you can see a little better. You have that little 1 in front of the x. This means the inverse function. So whenever you graph or whenever you find your inverse function, you always need to label it with the little 1, so f little 1 x, that exact symbolism. Okay. That way we know which is your original function and which is your inverse. And again, that reads the inverse of f of x. That's how you would say that symbol. Now, whenever you don't have a set of points or you don't have a graph, there is still a way to find your inverse functions. Make sure you have these steps. Right? I'm not going to spend too long on this slide. I'm going to explain the steps as I do them. But make sure you have these steps written out in your notes. And here we go. Now, when you're finding the inverse, the first thing you have to do is replace the f of x symbol with the y. So I'm going to rewrite this equation as y is equal to 4x minus 8. Then, remember back when we were finding the inverse from the points? We switched the x and the y. Okay, now we're going to do that here. All I'm going to do is I'm going to flip the x and the y. Only the x and the y are moving. So the x is going to come over here, and the y is going to go over there. Once I've done that, I'm going to solve for y. So plus 8. All I'm doing is solving for y at this point, which means I'm getting everything away from it. And now I have that y is equal to 1/4 x plus 2. All right, and how I got that, for those of you who missed it, x plus 8 over 4 is the same thing as x over 4 plus 8 over 4. Now, going back to the problem, once I have this equation written out, I have to put it in the proper notation. Like I said a few slides ago, whenever you have an inverse relation, you have to use the proper notation, otherwise I don't know it's your inverse relation. And there we go. Now the last thing I'm going to do with this problem is we're going to graph both the original relation and the inverse so that you can see how they relate. I'm going to do the original in blue and the inverse in green again, so it's keeping the same colors. So graphing my original, which is 4x minus 8. Oops, it actually goes off my graph bit, so here's -7, here's -8. So I'm going to graph my y-intercept of -8. And then I'm going to look up my slope. I have a slope of 4. So I'm going up 4 over 1. Up 1, 2, 3, 4. 1, 2, 3, 4. And then one more. 1, 2. Here is my original function. And I'm going to label it f of x. So that if you're not using two different colors, you can tell the difference. Next, my inverse. I'm going to graph my y-intercept first, which is right here. And then my slope is 1 over 4. So that's up 1 over 1, 2, 3, 4. And I'm going to go backwards. 4 right there. And there are my 2 lines. Again, make sure you label. Now this graph does not look like the last one. Okay, it doesn't look as nice and neat as the other one. However, if we were to graph our parent function, okay, you can see it follows the exact same pattern. The green line, your inverse, is still the original function reflected over the parent function. Okay, that is it. What I want you to do right now is just solve. You don't have to graph, just solve. Try to find the inverse of b down here, and then I will see you guys next time.